In this video, we are going to see how we can solve a question paper on ICSE Chemistry Class 10. So I have a practice paper for you, and you can see the questions, and I will also show how we will write the answers to these questions. Okay. So here we have section 1, 40 marks. It is compulsory, and question 1 says, fill in the blanks with appropriate words from the list. Do not copy sentences, and then words are given in the list. Then we will write the answers. Okay, so what you will do first is, you will write the question number 1A, and then in the blanks there are numbers given, so we will use these numbers. Number 1 here, what word will be used here? From the list we will choose, that is an element placed in group 17 is likely to be a number 1. So what is the answer? Group 1 is likely to be what? And contains 7 dash, sorry, this is group 17 is likely to be a dash and contains 7 dash. So what will come in the second dash? So you can find out. So what will be the answer to this? Then it will be, again it will dash in an electron to attain dash configuration. The elements placed in this group are called dash. So all these 5 blanks we are going to write. Okay, so in the first blank what will come? In group 17 is likely to be a what? It will be, from this list it is non-metal, likely to be a non-metal. So you write the answer non-metal, number 1. You are not copying everything, right? Then the second blank what will come? So it says 7 dash, what is it? 7 dash, 7 valence electrons. Valence electrons. Okay, and then what will come in the third blank? In the third blank, it will dash an electron to attain. It is 17. So atomic number 17 means the configuration is 2, 8 and 7. So it has 7 valence electrons. It will gain 1 electron to attain dash. So it will gain. The word gain is here in the list. So you write gain 1 electron to attain what? To obtain the stable electronic configuration or octet configuration. So in the list you have octet configuration. Octet configuration, that is the most suitable answer. And in number 5, what do you have in number 5? So number 5 is the elements placed in this group are called group 17. They are known as halogens. So you have the answer here. Halogens are also in the list. Halogens. Okay, so this first part is done. Now we will go to the second part, which says match the following. So we are going to match. Use numbers and alphabets only. That means no need to copy the words. We are going to only match. So you write part B, and here number 1, crystal lattice. It matches with what? Number 1, crystal lattice means it can match with the sodium chloride, which is an ionic compound, or ionic compound can match with this. So you can write sodium chloride, okay, because the next one, sodium chloride, will not match with sodium chloride, it will match with ionic. So crystal lattice is sodium chloride, so C. Number 2, in the second answer, what do you have? The second answer, so you have sodium chloride, number 2, that is an ionic compound, that is D, okay. And number 3, what is number 3? You can find here, number 3 is, what is number 3? Covalent compound. So covalent compound from the list, so you can find out phosphorus trichloride. So answer is E, okay. And then the fourth answer is phosphorus trichloride. Phosphorus trichloride is A, liquid at room temperature. It's a liquid, it's a covalent compound. And number 5 is the lone pair of electrons. So lone pair of electrons, which one has lone pair out of this? B, ammonia has the lone pair. Now you find there is one extra option in the second column that is given so that none of the answers are matching without your active involvement. Sometimes, you know, if 4 answers match correctly, the 5th automatically matches. So to avoid that thing, every answer this child should write with his own understanding. That is why extra options are given. Okay, now we have the next part, C, part C. So let us take C. C, here it says choose the correct answer. Do not copy words, use numbers and alphabets. So that is very easy. So you can write part 1. In part 1, what is the answer? So the question says lead bromide conducts electricity in solid state, aqueous state, molten state and liquid states. Part C, the molten state is the correct answer. You write C here. Okay. Now the second answer, an example of an active anode is graphite, iron, nickel, platinum. The correct answer is C. Nickel is the active anode. And then third part, in the third part we have during electrolysis, hydrogen ions are usually discharged at anode, cathode, both anode and cathode. Depends on the nature of anode. The correct answer is cathode. It is discharged at, hydrogen is discharged at cathode. So the answer is B. Okay, so this is how you write. You are not going to write the whole story. So take care of your writing, that you write only the required thing. Number 4, which one of the following is not a property of a cathode? We know cathode has excess of electron. Yes, that is why it is negative. It is correct. And cations are discharged at it. That is also correct. Cathode cations get discharged. And the C part loses electrons during electrolysis. That is also correct. Oxidation takes place at it. This is wrong, because at cathode reduction takes place. So the which one is not a property of the cathode? The answer is D. Okay, I think you got it. Now the fifth part here, part 5 is at the end of electro refining of impure copper, the weight of anode is greater than cathode. This is electro refining. Electro refining means the actual weight of the anode is transferred to the cathode and the impurities fall down. So that means the anode will have less mass compared to cathode. So B, anode is less than cathode. That is the correct one. And C says anode is equal to cathode. That is also wrong, and none of this is wrong. So the answer is B. So you write B here. Okay. Now, so we have finished all 5 parts. Now we are going to the next one, D. Part D. Name the gas evolved in the following reactions. Here the names of the gas has to be written. So number 1, caustic soda reacts with zinc. Caustic soda is sodium hydroxide. Zinc is an amphoteric metal. It reacts with zinc, forming sodium zincate and hydrogen. So the answer is hydrogen, the name of the gas. Now take care when you write the answer. Don't write formula. H2 if you write, or H you write, it is wrong. The question says name the gas. So you will write the name of the gas. So this is part 1. Now part 2, again you have to find the name of copper reacts with concentrated nitric acid. So copper with dilute nitric acid and concentrated nitric acid, different reaction. With concentrated, the gas evolved is reddish brown colored nitrogen dioxide. You will not write all the story. You will write only the name of the gas, nitrogen dioxide, and no formulae. Okay, please remember that. Now we have the third answer. So if something goes wrong, please write, strike off and write again. Okay, so number 3, copper reacts with concentrated sulfuric acid. Copper and sulfuric acid. Whenever concentrated sulfuric acid reacts, the gas evolved is sulfur dioxide. So the answer is sulfur dioxide. And then the fourth answer here, number 4, dilute hydrochloric acid reacts with sodium thiosulfate. Sodium thiosulfate. Sodium thiosulfate has the formula of Na2S2O3. The reaction, sodium chloride will be formed, water will be formed, and then sulfur will be formed, and also sulfur dioxide. The gas evolved is again sulfur dioxide. We are supposed to write only the name of the gas that is evolved. So answer is sulfur dioxide. Number 5, sodium hydroxide reacts with ammonium carbonate. Sodium hydroxide is alkali, reacts with ammonium carbonate is ammonium salt. The gas evolved is ammonia. We know ammonium salts react with alkali, giving ammonia gas. So that is the answer. So this part D is also answered. Now we will go to the next part of the question paper. So that is part E. Where is part E? So in part E, what are they asking? They are asking identify the anion present here. So the anion, which anion is present in this? So we will write part E here, and then number 1. So substance A, when reacted with dilute hydrochloric acid, it is giving out a gas which turns lead acetate paper silvery black. Which gas turns lead acetate paper silvery black? It is hydrogen sulfide. If hydrogen sulfide is evolved, the anion present will be sulfide. So you will write sulfide. Identify. So sulfide, or you may write the S minus minus formula is acceptable here because it says identify. It does not say name or formula. So any one of that will be correct. Second part of the answer. Solution B, when treated with barium chloride solution, gave a white precipitate which is insoluble in concentrated hydrochloric acid. So it should be sulfate. Barium sulfate is produced. Sulfate is the answer, or you may write the formula SO4 minus minus. Okay. The third one is, when substance C is reacted with dilute hydrochloric acid, gives out a gas which turns potassium dichromate paper green. So potassium dichromate paper turns green means sulfur dioxide gas is evolved. That means the anion present is sulfite. Sulfite. So be careful with the spellings here. Sulfide, sulfate and sulfite. Sulfite is SO3 minus minus. Now part 4. When substance D is heated with concentrated sulfuric acid, a reddish brown gas is evolved. Reddish brown gas means it is nitrogen dioxide. So the anion present is nitrate or NO3 minus. Part 5. When substance E is reacted with dilute hydrochloric acid, a colorless, odorless gas evolved which turns calcium hydroxide solution turbid. Calcium hydroxide is lime water. It is turning turbid means it is turning milky. So the gas is carbon dioxide. So the anion present is carbonate or CO3 minus minus. I think this is clear to you. Now let us go to the next part. Part F. Part F is asking for balanced chemical equations. Please always write balanced equations. Never write unbalanced equations, because unbalanced means it is not an equation at all. No mark will be given for that. So first one, here the dilute hydrochloric acid is reacting with this following. Number 1 is sodium bicarbonate. Sodium bicarbonate, what is the formula? NaHCO3. Otherwise, sodium hydrogen carbonate reacting with the dilute hydrochloric acid. So what will be formed? Bicarbonate and acid will give salt plus water plus carbon dioxide. Salt of the metal NaCl and then water and carbon dioxide. It is balanced already, so no need to balance because this is Na plus and HCO3 minus, univalent. HCl also H plus and Cl minus, univalent. So it is balanced without any problem. Now second part of this answer, what you can see here, the second part is saying calcium sulfite, CaSO3. Calcium sulfite is here. So you write the formula CaSO3 plus HCl, dilute hydrochloric acid. Now see, calcium is divalent, so 2 moles of HCl is required. So you can put 2 already here. Formula of the salt formed is CaCl2. Sulfite plus acid will give salt plus water plus sulfur dioxide plus H2O and SO2. It is balanced. Okay, if you can balance the valences, then equation will get balanced on its own. Okay, now the next part of the question is the third part, which says magnesium sulfide. So number 3, you write MgS, magnesium sulfide, plus HCl. Again, magnesium is divalent, plus 2. So 2 HCl will be required. So the salt produced will be MgCl2. And sulfide plus acid, it will be salt plus hydrogen sulfide, H2S will be released. So this is also balanced. Number 4, we have zinc here. Zinc and dilute hydrochloric acid. Zinc metal plus dilute hydrochloric acid. So zinc is divalent, as I already said. Valence is 2. So you will take 2 HCl. So you will get ZnCl2. Okay, ZnCl is not produced. ZnCl2. because zinc is divalent, Cl minus, it is univalent. Plus what will be formed? Hydrogen will be evolved. Metal plus acid, active metal plus acid, hydrogen will be evolved. Okay. And number 5, here we have potassium hydroxide is asked. So KOH plus HCl, univalent. So nothing to do, it is balanced. Salt plus water, KCl plus H2O. Salt plus water is produced, it is balanced. So we have made 5 balanced equations. Now part G. The next one is, they are asking here, the question is, ammonia gas is passed through following solutions in small quantities. State your observations. Do not write formulae or equations. So when our observations are asked, you must write observation. What is observation? What you see, what you can smell, what you can hear. So these are the observations. What your sense organs tell you. So there you will not write name of substances. You do not write formulae. You do not write any equation. Okay, that is what is required when you write observation. So here it says ammonia gas is passed through these solutions. They are aqueous solutions. You must understand, when ammonia gas passes through water, any aqueous solution, the first thing produced is NH4OH, ammonium hydroxide is formed. So it will form NH4 plus ions and OH minus ion. So the substance that is reacting here is actually ammonium hydroxide. Okay, so we are going to see that copper 2 sulfate. Copper 2 sulfate is a blue colored solution, and we must have studied it under analytical chemistry. When ammonium hydroxide reacts, it will form a pale blue PPT. So the number 1, the observation is pale blue precipitate. Shortly we write PPT, or you may write as whitish blue precipitate. It is also known as whitish blue precipitate, PPT. Okay. Now the second part of the answer is, here it says iron 3 chloride, that is FeCl3, ammonium hydroxide, we know we will get a brown precipitate. We get a brown precipitate. That is the observation. We are not going to write anything else there, right? In the third part, we have iron 2 sulfate, that is ferrous sulfate, FeSO4. You will get a pale green precipitate, PPT, or some people call it as dirty green precipitate. Dirty green precipitate. Okay, dirty green precipitate or pale green precipitate. Now the next part of the question here we have is lead nitrate. Lead nitrate is a colorless solution, so you can write lead nitrate and ammonium hydroxide. Lead hydroxide will be formed, which is a white precipitate. White precipitate. Okay, so and then it talks about the fifth one. The fifth part, here we have Nessler's reagent. We know ammonia solution and Nessler's reagent and ammonium ions, NH4 plus ion, will give you a brown precipitate. Brown precipitate. So this answer is also done. Then we have the next part coming up, H. Under H you have, the question says, choose your answer from the list of substances given. Here they have given a list of substances. So you have to find out which one matches with this. Number 1 has substance that turns black on heating. Which substance turns black here? From here in the list you have copper 2 nitrate. Copper 2 nitrate on heating will give copper 2 oxide, which is a black colored substance. So number 1 is copper 2 nitrate. Don't make your own answers. Choose the answer from the given list. Whatever is given there, right? Don't change it into formula or modify it. Never do that. Always use the options given there. Okay. Then second part says, and metal nitrate that gives no colored gas on heating. Which metal nitrate on heating gives no colored gas? Out of this, sodium nitrate. Yes. Yeah. Sodium nitrate or potassium nitrate. Any one of that can be used here, potassium nitrate or sodium nitrate. Both of them will give oxygen gas, so no colored gas. So the second answer is, you may write sodium nitrate or you may write potassium nitrate. Okay. Now the third part of this answer, in the third we have a substance that decrepitates on heating. A substance which bursts like mustard seeds put on oil, that is called decrepitation, is either sodium chloride or lead nitrate. We have lead nitrate here. Yeah, it is lead nitrate decrepitates on heating. Please remember these substances, it decrepitates on heating. And number 4, we have a substance which on heating with concentrated sulfuric acid gives nitric acid vapors. Yes, nitric acid is obtained from concentrated sulfuric acid using either sodium nitrate or potassium nitrate. We have already used sodium nitrate, so we may write the next option available here is potassium nitrate. So let us write potassium nitrate. Now what is the fifth part? In the fifth part we have a substance, no, this one, fifth one is a substance capable of oxidizing sulfur to sulfuric acid. When sulfur reacts with one substance, it changes to sulfuric acid. Which substance is that? It is nitric acid. Concentrated nitric acid can oxidize sulfur to sulfuric acid. Please remember to write concentrated. If you simply write nitric acid, it will be incorrect. You have to specify it is concentrated nitric acid. By this, we have finished section A. Now we are going to section B. In section B, let us take question number 2. Here you have to answer any 4 questions, but in practice, we will try to solve all questions. Okay. So here, the first question, question number 2, write balanced equations. They have asked number of balanced equations here. Number 1, so let us take part A, number 1. Okay, number 1 is iron pyrite is roasted. What is iron pyrite? Iron pyrite is FeS2. Roasting means heating in the presence of oxygen. So you get the product Fe2O3 plus SO2. We have learned these reactions. So this is odd number, so we will double it. 2 2s are 4 Fe, so we write 4 FeS2 here. 4 2s are 8 sulfur, so we will take 8 SO2 here. Now oxygen, 2 3s are 6 and 8 2s are 16. 16 and 6, 22, so there should be 11 O2 here. So that is how we balance the equations. Okay. Now the second part of this question, which equation is asked? Dilute sulfuric acid reacts with sodium sulfite. Sodium sulfite is Na2SO3 plus dilute sulfuric acid H2SO4. What do you get? Salt plus water plus sulfur dioxide. Salt of the acid Na2SO4 plus water, and then you have sulfur dioxide. It is balanced because Na2Na is already here, and this is a divalent dibasic acid, so it is balanced. Number 3. The third equation asked here is concentrated sulfuric acid reacts with sulfur trioxide. This is in the contact process. Concentrated sulfuric acid plus sulfur trioxide SO3. We know it produces oleum or pyrosulfuric acid H2S2O7. This equation is also self-balanced equation. Next question asked here is number 4. Sulfur dioxide is mixed with air and passed over heated vanadium pentoxide catalyst under suitable pressure. So this is a reaction in the contact tower again. Sulfur dioxide is mixed with air, that is oxygen, and we are passing it over heated vanadium pentoxide catalyst. So it will be formed, sulfur trioxide will be formed. This equation we are familiar with. So we can balance this. 2SO2 plus O2 gives 2SO3. It is a reversible reaction. It is an isothermic reaction. Now the fifth part of the question, the equation asked, fifth equation is sulfur burns in air. When sulfur burns in air, what is produced? Sulfur dioxide is produced. S plus O2 gives SO2. Very simple equation. Sixth question is pyrosulfuric acid is diluted with water. Pyrosulfuric acid is otherwise called oleum, which is having the formula H2S2O7, diluted with water, adding water. So the product will be 2 molecules of sulfuric acid, 2H2SO4. This is again reaction from the contact process. Let us go to the next question. So there are 6 parts in this. Now part B of this question. Part B, under B they have name all the products formed in the following reaction. See, go through the wordings of the questions. Read every word very carefully. It says all the products of the following reactions. So you have to write the name of all the products. The first reaction is sulfur reacts with concentrated nitric acid. So sulfur reacts with concentrated nitric acid. What will be the product? Number 1 will be, it will form sulfur is oxidized to sulfuric acid. And then water and then nitrogen dioxide. Concentrated nitric acid forms nitrogen dioxide. Please write names only, don't write formulae, because it says name all the products. Okay, now taking the second question here. Concentrated sulfuric acid is added to sugar crystals. So sugar crystals, sugar has a formula of C12H22O11. Sugar, it gets charred. So the product will be carbon or sugar charcoal plus water vapor. Carbon or sugar charcoal and water vapor are the products. Concentrated sulfuric acid is added to sugar crystals. Then the next part, third, says dilute sulfuric acid is added to barium chloride solution. Dilute sulfuric acid is H2SO4, barium chloride is BaCl2. A double decomposition reaction, precipitation happens. Have white precipitate of barium sulfate. We will not write white precipitate. We write the name of the product, barium sulfate. Yes, plus hydrochloric acid. Hydrochloric acid. This is what is formed. Okay. Now the fourth part in this question is sodium chloride solution and silver nitrate solutions are mixed together. Double decomposition reaction again. Sodium chloride and silver nitrate. The product will be sodium nitrate plus silver chloride. Okay. So question 2 is over. Now let us take question 3. Question 3 is study the scheme and answer the following questions. Okay, questions that follow. So here is a scheme. Now what are they asking? Now first thing is write balance equation for conversion A. Conversion A is H2SO4 to Na2SO4 without using an alkali. Okay, so alkali should not be used. So what can be used then? H2SO4 can react with the metal, alkali cannot be used, so metal oxide or hydroxide cannot be used, so you can use a metal carbonate. Okay, so sulfuric acid has to be used, so you may use Na2CO3. Na2CO3 plus H2SO4, you get Na2SO4. Na2SO4 plus H2O plus CO2. So this is the one. So this is the part 1 of this question. Second question, what are they asking in the second part? The second part, write an equation for conversion B. What is B? H2SO4 to HCl. Okay, we can use NaCl plus con H2SO4. We know below 200 degrees Celsius we have NaHSO4 plus HCl. Okay, so got it. This equation is done. Now the third part of the question says conversion C. Equation for conversion C using sodium thiosulfate. Okay, HCl to SO2. This question has already come in the first part. So we take sodium thiosulfate, that is Na2S2O3 plus we have to use from HCl, no? So it is hydrochloric acid, dilute hydrochloric acid. You get the salt NaCl plus H2O plus sulfur S plus SO2. These are the products, Na2CO3, SO3, Na2S2O3. So it is 2 NaCl and 2 HCl. So there will be 2 chlorine, 2 Na. The rest is done. Number 4. What is the fourth part in this question? Number 4 is write an equation for conversion D using sodium sulfite. D is HNO3 to SO2. Sodium sulfite has to be used. Okay, so HNO3 and sodium sulfite. Na2SO3 plus HNO3. Okay, so what you get here? Salt plus water plus sulfur dioxide. NaNO3. Now see Na2, 2 sodium, so 2 HNO3. 2 NaNO3 plus H2O and SO2. It is done. Number 5. The fifth part of this question is which form of nitric acid, dilute or concentrated, will you use for conversion E? Conversion E is HNO3 to H2SO4. Yes, here sulfur plus corn nitric acid is used. So here it will be, the answer will be concentrated. Which form is used? Just write concentrated. That is enough. And the next part says concentrated sulfuric acid is a hygroscopic liquid. True or false? Hygroscopic liquid means it will absorb moisture from the air and will not change its physical states. It is true. Concentrated sulfuric acid is hygroscopic. It is correct. Then number 7. What is the basicity of hydrochloric acid? Number 7. Hydrochloric acid is monobasic. It has basicity 1 or 1. Simply writing 1 also is correct. Part 8 of the question, the 8th part. 8 is write a balance equation for conversion A using a metal oxide. Where is conversion A? A is here, H2SO4 to Na2SO4 using a metal oxide. So Na2SO4 we need. So we need to take sodium oxide, Na2O plus H2SO4, dilute sulfuric acid. You get salt plus water. This metal oxide is base. So base plus acid is salt plus water, Na2SO4 plus H2O. Okay. And number 9. Now what is number 9? Ninth part of the question is write a balanced chemical equation for conversion F. What is F? H2SO4 to NaHSO4. So here you can write any equation here. You may take NaCl. The previous equation, this one can be rewritten again. NaCl plus H2SO4 will give NaHSO4 plus HCl. You can write that. Okay. And then we have the last one. What kind of salt is NaHSO4? Number 10. Sodium NaHSO4 is acid salt. Or you may write acidic salt, acid salt or acidic salt. So we have solved question number 3. Now we have to go to question number 4. So question number 4. Question number 4. Question number 4 also has a scheme here, reference to the scheme given below. So let us see the scheme and try to answer one by one. Number 1 is write balance equation for conversions A to D. Okay. So A to D, 4 equations are asked. What is A here? Conversion A is Mg3N2 to NS3. So Mg3N2, magnesium nitride, and we need to react it so that the product we get is ammonia. Magnesium nitride reacts with water. So you get MgOH whole twice plus NH3. So 3 MgOH whole twice, 2 NH3. So and 6 H2O. Okay. So it is balanced. Now this is conversion A. Now what is B? Conversion B. A to D they are asking. So what is B? B is NS3 to NO. Ammonia to nitric oxide. Ammonia, NS3, can be oxidized in the presence of heated platinum at 800 degrees Celsius. You get NO and H2O, nitric oxide. So 4, 5, 4 and 6. 4, 5, 4, 6. This equation is usually referred to as 4, 5, 4, 6. Now part C. The C here is NO converted to NO2. So for that simple oxidation in the Ostwald's process, NO reacts with O2 gives NO2. So 2NO plus O2 gives 2NO2. It's an endothermic reaction. Anyway, that is not required here. Now the D part of this one is NO2 changing to HNO3. How do we change NO2 to HNO3? NO2 can react with oxygen and water. NO2 plus O2 plus H2O. So what you get? HNO3. This is again from the Ostwald's process. So we have 4 HNO3, 4NO2 and 2H2 is balanced. Now the second part of the question. First part was asking reactions for conversions A to D. Second part says name the catalyst used for conversion B. What is B? Ammonia changing to, so name the catalyst. So it is platinum. So platinum. Don't write PT here. It is name. Okay. Number 3. What is the third question here? Number 3 is name the industrial process which involves reaction B. As I already said, it is Ostwald's process. Ostwald's process. Number 4. What is the fourth part of this? State the temperature required for conversion C. What is C? NO changing to NO2. So it is 50 to 60 degrees Celsius. It is in the Ostwald's process. Now part 5. What is part 5? Write balance equation for conversion F and G using sodium hydroxide. What is F? F is here. Ammonium nitrate to ammonia using sodium hydroxide. Okay. NH4NO3 is ammonium salt plus alkali NaOH. Ammonium salt plus alkali will give salt plus water plus ammonia. Salt of this sodium NaNO3 plus water and ammonia NH3. So that is done. This is for conversion F. What is G? Conversion G. They are asking F and G. So G is NH4Cl to NH3. Okay. Again using sodium hydroxide. So NH4Cl. This is another ammonium salt. Again alkali sodium hydroxide is used. So you get salt, that is NaCl plus water and ammonia. Okay. Right. Then question number 6 here. Write balanced equations for conversion E without using a salt. What is E? HNO3 changing to NH4NO3 without using a salt. Okay, so then we can use the alkali, that is NH4OH can be used, ammonium hydroxide plus the acid HNO3 changes to NH4NO3 plus H2O. Okay, salt plus water, acid plus alkali, salt plus water. So that is the 6th part. Now what is the 7th part of the question? Okay, that is done. Yeah, I think 10 parts are done. This is 4 plus 5. Yes, 10 parts done. Question number 5 now. Question number 5 has different parts. How can you differentiate between the following pairs of substances using the reagents given? Okay. Write what you will do and give distinct observations in each case. Okay. Do not write formulae, name of the products or equations. Okay. Again, observations. The emphasis is on adding a reagent and emphasis. The first part is iron 2 chloride and iron 3 chloride solution using sodium hydroxide solution. So what we will do, part A, iron 3 chloride and iron 2 chloride. Okay. Using sodium hydroxide solution. So what you will do, add, they are saying using sodium hydroxide solution. Add sodium hydroxide solution to both the solution. Okay. Now iron 2 chloride, that is FeCl2, and the other one is iron 3 chloride, FeCl3. We have to give distinct observations in each case. This one gives pale green precipitate. Okay, we have studied under analytical chemistry. FeCl3 will give a brown PPT. That is done. Now part B. Part B is, they are asking zinc nitrate solution, calcium nitrate solution. Both have nitrate. The difference is zinc and calcium using sodium hydroxide solution. Okay. So what you will write, add NaOH solution, sodium hydroxide solution to both. Okay. Now zinc nitrate solution, ZnNO3 whole twice, and then calcium nitrate, CaNO3 whole twice. So what you will write, you will add NaOH solution to both in excess. Here you get white PPT. PPT dissolves in excess NaOH. When you add excess NaOH, the PPT dissolves. Here you have again white PPT White PPT is precipitate insoluble in excess. This is not dissolved, insoluble in excess of NaOH. Okay, so it is differentiated. Now let's take part C. In C, what is asked? They are saying sodium chloride solution and sodium nitrate solution. Sodium is common in both chloride and nitrate. The differentiate using silver nitrate. So what you will do first, add silver nitrate solution. Add silver nitrate solution to both. Sodium chloride, NaCl solution. What comes? The other one is sodium nitrate, NaNO3 solution. What comes? NaCl solution, white PPT is formed, or curdy white PPT is formed. Here, no PPT. Differentiated. Now let us go to the next part of that question. That is the part D. We have D here. D is sodium sulfate solution and sodium nitrate solution using barium chloride. Okay. What you will do? Add barium chloride solution to both. Barium chloride solution to both. Okay. The first substance is sodium sulfate, Na2SO4. The second substance is sodium nitrate, NaNO3. We know barium chloride gives white PPT with sulfate. Sodium sulfate, you get white PPT. With nitrate, it does not give any PPT, so no PPT. That is done. Now part E. Part E is, we are saying concentrated and dilute hydrochloric acid using manganese 4 oxide. Okay. So what you can do, add manganese 4 oxide, that is MnO2, to both and heat. Both means one is dilute HCl, the other one is con HCl. Dilute HCl, no visible change. Con HCl, a reaction will take place, chlorine is evolved, so greenish yellow gas evolved. Greenish yellow gas evolved. Okay, and then yeah, that part is over. Now let us go to the next question, that is question number 6. Question 6, we have answered the following questions with reference to the electrolysis of lead bromide. Okay, 5 parts are there. So let us write part A and number 1. What is number 1? They are saying, what is the anode made up of? It is reference to lead bromide, electrolysis of lead bromide. What is the anode made up of? Anode is made up of graphite. We know it is only graphite here. Okay. And second answer here is, write equation with the reaction taking place at the anode. At anode, we have the bromide ions coming here, Br minus, comes to the anode, forms neutral Br, and electron is given to the anode. Anode has deficiency of electrons, so it gives electron to the anode. That much is sufficient. Don't try to make it Br2 and all that. That is not required. And then the third part, what is the container used for the electrolysis made up of? It is made up of silica. Made up of silica. Okay, this much is enough. Don't write sentences and all. Then we have the fourth part. What is the physical state in which lead bromide conducts is electrolyzed? It is molten. Molten state. Okay, this already came in part 1. Then we have the next part. What kind of reaction, oxidation or reduction, takes place at anode? When it is anode, it is always oxidation. Please remember that. Anode means oxidation, cathode means reduction. Now A part is done. Now part B. Part B of question number 6. So state whether the following substances are strong, weak or non-electrolyte. That's what we have to write here now. Okay, so let us write one by one. Part 1. Number 1 is, we have here ammonium chloride solution is a strong electrolyte. Okay. Second part, we have sugar solution, non-electrolyte. Third part, we have acetic acid is a weak acid, it's a weak electrolyte. Number 4 is dilute hydrochloric acid is a strong electrolyte. Number 5, we have solid sodium chloride. In the solid form, it does not conduct. It's a non-electrolyte. Number 6, carbon tetrachloride is a non-polar covalent compound. No ions formed. It is a non-electrolyte. Number 7 is sodium hydroxide solution. It's a strong alkali, has strong electrolyte. Number 8. What is number 8? Number 8 is lime water. Lime water is a weak alkali, so it's a weak electrolyte. Number 9. Number 9, we have copper wire. Copper wire conducts electricity, but not by the movement of ions. Even though it is a good conductor, it is a non-electrolyte. It's a non-electrolyte. And then we have one more part. That is the 10th part. Part 10th is soda water. Soda water is carbon dioxide dissolved in water. Carbonic acid, weak acid, is a weak electrolyte. So question 6 part B is done. Oh, I'm sorry, this is part B. Now, yeah, part B, part A and part B, both are done now. Yes, here is part A. After this part B, you have all this. There are 10 parts, half mark is, so it is 5 and this is 5, 10. Yes. So question 6 is done. Now we have question 7. Question number 7 is, yes, make electron dot figures of the following. Electron dot figures of the following. So first one is methane. Please make it using black pen. Don't use pencil. Okay. Methane has the structure carbon with 4 valence electrons and hydrogen, each one sharing 1 electron. 4 hydrogens are there. So this is the structure of methane. Please don't make circles and other things which is not part of the structure. That is made for understanding in some books. No need to do that. Second part. The second part is carbon tetrachloride. Carbon tetrachloride has a central atom carbon, 4 electrons. Carbon has the configuration of 2, 4. Okay, the rough work you can do here, 2, 4. So 4 valence electron. Chlorine has configuration 2, 8, 7. So 7 electrons in the chlorine. So there are 4 chlorine atoms. Now each chlorine atom is sharing 1 electron. See, this chlorine has 4, 6 and 1 is shared here. Okay, and this one also has 2, 4, 6 and 1 is shared 7. This one also has 2, 4, 6 and 1 is shared here 7. This chlorine also has 2, 4, 6 and 1 is shared here. So the duplet, not duplet, carbon 2 electrons shared here. So total it makes octet. Chlorine also makes octet. So it is complete. Now what is the third structure? The third one asked here is ammonium ion. See, ammonium ion and hydronium ion. Any one of this will be there in every question paper. So please practice that. Ammonium ion has a central atom nitrogen. Yes, with the nitrogen has got the configuration 2, 5. So 5 electrons. 1 electron each on 3 sides and there is a lone pair on the other side. So ammonium ion is 3 hydrogens. So 3 covalent bonds. The fourth one is a hydrogen ion which has no electron. It has come here with a positive charge. So the molecule put in a square bracket and a plus charge. Please make it like this. Okay. And then number 4. The fourth structure here is hydronium ion. Hydronium ion has oxygen in the middle with the 2 lone pairs on 2 sides. 2 hydrogens are combining on 2 sides, making it 2 covalent bonds. Now these lone pairs, a proton or a hydrogen ion which has no electron is coming here. So it will bring a positive charge here. So these are the 4 structures that are asked in this question. Then the second word B part is part B of question 7. Here we have an atom of an element has 9 protons. 9 protons means 9 electrons also. So what will be the configuration? 2, 7 is the configuration. Okay. So this is the rough work you need to do first. Now try to answer the question. Number 1, state its position in the periodic table. The configuration is 2, 7. So the position is number of orbits is 2. So it is in the second period. So part 1, You will answer period 2. And 7 valence electrons, so group 17. Group 17. Period and group, both you will mention, then the position is correct. Now, second part of this question is, state the type of bond formed between an atom of this element and sodium atom. Sodium has the configuration 2, 8, 1. So it will donate its electron. This one has a deficiency of 1 electron for octet. So this will gain. So transfer of electrons. So what is formed here? The type of bond will be electrovalent bond. Electrovalent bond, or otherwise known as ionic bond. Okay. Now the third part of this question, part 3, is name the alkali metal of the period in which this element is placed. This is placed in second period. So which alkali metal is there in the second period, which is lithium in the second period. Okay. Now what is the fourth part of this question? Part 4 is, how many positive or negative charges will be there in the ion of this element? This element has 7 valence electron. It will gain 1 electron, so there will be 1 negative charge. So minus 1 charge will be the charge on this ion, in its ion. How many positive or negative? Or you may write 1 negative charge. This is how you answer this question. Now there is part C. Part C of this question. Part C says, what do you mean by a coordinate bond? You have to write a proper definition for coordinate bond. A bond formed, here answer has to be in sentence, formed by the sharing of electrons between two atoms in which only one of the combining atoms contribute both the electrons for sharing. Okay, so part C is done. What is meant by coordinate bond? Now, part D is define ionization potential. D, ionization potential, the amount of energy required to remove an electron from the outermost orbit of an atom. So this is the answer for this. So we have completed the paper. I hope you have understood how we solve this. Now it is important to see that we will write sentences only in such answers where definitions are asked. Otherwise we are not writing sentences. We are writing our answers in very simple terms and following the instructions of the question paper. Where only numbers and alphabets are to be used, use only them. Where names are asked, write only names. And where formula is asked, make only formula. Equations are, write only equations. So just follow the words of the questions carefully and do accordingly. I hope you understood. Please practice this paper again and again. I'll come with another video shortly. So till then, God bless you.